The last part of our outline for Chapter 1 is going to be an algebra review. So if you do not know the order of operations, which is sometimes abbreviated with PEMDAS, these are the steps. You do everything in parentheses first, then the E is for exponents, which means powers, square roots, anything like that, and then multiply and divide, and that goes from left to right, and then finally you would add or subtract from left to right. I also have these two YouTube videos. You guys actually have seen them already, but if you want more of a review and you need to go back over order of operations or solving equations, and that means rearranging an equation and solving for a particular variable, these are where you can find those links. Next, we're going to review direct and inverse relationships. You should have seen these when we've done some of our graphing activities in class, but I just wanted to make sure we go over them and learn how to write a proportionality instead of an actual equation. So first, when you're considering a relationship between two variables, that should say two variables, sorry. On opposite sides of an equal sign, we can assume that all the other variables and constants are equal to one another, and we would replace that equal sign with the proportionality sign, which is the Greek letter alpha. So if two variables are directly proportional to each other, the entire equation is an f with the subscript of a g, and that's equal to an m times g. This is going to be a formula we'll get to in a couple of chapters, but it means that the gravitational force is equal to mass times acceleration due to gravity. Well, let's say I only wanted to compare two of those variables instead of being interested in all of them. So if I want to compare the force of gravity, so the f with the subscript of a g, to the mass, those are going to be directly related to each other. So I would write that as f with the subscript of a g, the proportional sign, and then little m for the mass. What this does is it allows us to compare two variables without actually having to plug numbers in or to take into account every single variable in the formula. So I'm only interested in comparing two quantities. I can use a proportionality to do that. If two variables are directly proportional to each other, it means as one of them goes up or increases, the other one behaves in the same way. So if I, in this case, were to look at a mass, if my mass increased, my force of gravity would increase as well. And it works the opposite way also. If one variable decreases, the other one decreases. So directly proportional means my two quantities are going to behave in the same manner. The other proportionality that we're going to see most common is going to be inversely proportional, and I'm not quite sure why that printed as question marks, but it should say V equals D over T. And you may have done that equation in your math classes where rate is distance over time. We're going to talk about the rate that you're used to as a velocity or a speed. So we would say speed is distance over time. So let's say I want to compare the speed to the time. Because speed would be considered to be in a numerator on one side of the equation, time is in the denominator. It's in the opposite part of a fraction on the other side of the equation. That lets us know that these are inversely related to each other. So when I look at the proportionality, I would say the speed is proportional to 1 over the time. Or if you wanted to write it out in more of a fraction term, it would look like that. Speed is proportional to 1 over time. In this case, the variables or the quantities are going to behave in the opposite way as each other. Now you should be familiar with that idea from some of the lab activities that we did, but using this example, if we're interested in the speed and how it relates to the time, let's say my speed increased, so if I have something that goes faster, it can move more quickly, which means it's going to take less time. So a larger speed is going to be a smaller time, and vice versa. And finally, the last thing I want us to look at would be the ability to convert between meters per second to kilometers per hour, and then also the other direction. So this is why units are really important. If I asked you which is bigger, 60 meters per second or 60 kilometers per hour, if I didn't have those units there, both of those numbers are 60, and you would tell me that they are the same. However, because of the units, that indicates that these are not going to be equal to each other. Okay, so let's convert one of them and see how they actually compare. So I'm going to start with 60 meters per second and convert it to kilometers per hour. So what I would do is set up my parentheses. I want the meters here to cancel. So I'm going to put meters on the bottom, and I'm looking to convert to kilometers. So that means my kilometers are going to go on top, and that makes my units work out. Now you need to know how many meters are in a kilometer. So I would say 1 kilometer is 1,000 meters, or you could also say 10 to the third if you wanted to use kilos power of 10 equivalent. And then now I need the seconds to cancel. You could convert seconds to minutes and then minutes to hours, but this will save you a step. So if I want my seconds to cancel, I'm going to put those on top, and I'm going to say 1 hour on the bottom. And you should be able to figure out that there are 3,600 seconds in 1 hour. So that comes from 60 seconds in a minute times 60 minutes in an hour is how I got 3,600. From this point, all I need to do is multiply across everything in the numerators. So I have 60 times 1 kilometer times 3,600. Remember, those seconds canceled out on the top, so I don't have to write them. And then on the bottom, anything that did not cancel turns out to be 1,000 times 1 hour in this case. So I simply plug those into my calculator, and I end up with units of kilometers per hour. And this turns out to be 216 kilometers per hour, which now when we go to compare them, if we compare numbers that have the same units, it's really easy to see now that 216 is much, much larger than 60. So now we're going to work a second example problem and convert the other direction as well. So you were given the speed formula earlier, so I'm going to say speed is distance over time. You should be able to tell that 13 kilometers is a type of length. We're going to plug that in for distance, and then our 2 hours is going to be our time. So I'm just going to plug those numbers in and say 13 kilometers over 2 hours. And this is going to give us 6.5 kilometers per hour. So that is the answer to my speed for that unit. Now we were asked to find also the answer in terms of meters per second. You could have converted 13 kilometers to meters first, and then 2 hours to seconds, and then plugged into your equation, or we can start from our answer and convert from there, which is what I'm going to do. Now you should notice that the conversion factors are going to be the same as the problem we just did in number 1, but the ratios are going to be flipped. So this time I want kilometers to cancel, so I'm going to put my 1 kilometer on the bottom and 1,000 meters on the top. And it looks like that. And next I want hours to cancel, so I'm going to say 1 hour is equivalent to 3,600 seconds. So that cancels. And then whatever's left over, I've got 6.5 times 1,000 meters times 1. And then in my denominator, I've got 1, and then 3,600 seconds is listed. So we type that into our calculator, and that gives us a final answer of 1.8 meters per second. So on your test, you'll need to know how to convert from meters per second to kilometers per hour, and also the other direction. And then lastly, I just wanted to point out that you do have a study guide in your notes. This is not an assignment, but this will help you narrow down how to study for your test. You'll be given multiple choice questions about all of these things, so you can see there's some vocabulary there for you, and then a few things about other information that was in your notes. And then finally, you'll have some free response questions where you'll be asked to rearrange equations for a given variable. So that would be the solving literal equations video that you watched. You'll need to be able to read and interpret graphs. And then also you might be asked to plot a graph and draw a best fit line and find the slope. and also write an equation for that best fit line. So just remember that all of that information is in your notes, and if you need help, you can come in and make an appointment for tutorials.